Greetings everyone, good evening. This is Obi-Wan Pez for N Simplex Pachinko. We're going to be looking at doing some more Calc II stuff tonight, and obviously requests if anyone has any. And there is also a new challenge that has been thrown out by 3 Blue 1 Brown's Grant. I probably should know his last name. Oh well. So yes, Grant from 3 Blue 1 Brown has put out a challenge to mathematics educators especially, but really anybody who's decent at explaining stuff, to try to get mathematical concepts out in the public space, out onto YouTube especially, but, you know, really anywhere. And so I'd like to do a little bit of a discussion on what I might try to, like, I guess outline or storyboard what I've got going, although the whiteboard app is not having it tonight, so that's gonna be fun. Now, in theory, I could use OneNote, however, that is plastered with both my actual name and my place of work, because it is their software, not mine. Yeah, that would not be ideal. I do not want to dox myself yet again. So for the moment, we're just going to try to get the whiteboard to work. And if it's not working, I guess we can pop over to... there was something I was doing the other day that had a, like, conversion to math thing on it. It wasn't OneNote. It wasn't whiteboard. Now I can't remember what it is. At any rate, yeah, so my basic idea for this is there are two major topics that I was looking at, with potentially doing the 3 Blue 1 Brown challenge, which I believe is called Sum 1, S-O-M-E number 1. I think that's right. The first would be the description of absolute value, which I invented and have done a few times on this channel, which includes the idea that we really need to focus on distances and talking about absolute values in terms of distances. And the other would be the beginnings of trigonometry, which specifically I would be looking at developing the unit circle from the standpoint of creating just like a circle, and then talking about how we can think of this in terms of circumference, and then when we look at circumference, we're also looking at, by nature, any size circle is going to have a certain number of radii measurements going around the outer edge of it. And in doing so, this creates the unit circle, again starting from 0 and increasing in angle until we get all the way back around to 2 pi times the number of radii that we had. So there are kind of two ways that I can go with this. I figure I could probably actually submit both, because they will accept just about anything. Alright, hang on one sec. Anyway. So yeah, one of two ways we can go with that. And it is... like I said, I could probably submit both. I don't think they're very picky. They will take just about any submissions, and then they will determine who the winners are. I don't remember exactly what the idea is, but I believe that like your video with explanation will be put into production with 3 Blue 1 Brown and or Khan Academy. So that would be really exciting if I could get something like that going. It'd be cool. I don't think it's gonna happen because there are so many other people who are way better than me, but guy can dream, right? In the last 2 weeks, I have put in both a solid-state drive and doubled my RAM. So, in theory, this should be better than what's happening right now. Alright, all other tasks have been suspended. Alright, whiteboard. Well, that's promising. So this does mean it at least has advanced onto getting the pages up. There we go. Alright, now where are my other notes? Yeah, there we go. Yeah, I guess this is also another one we could do, but it's less interesting. It's more just math. We've also already done this, so I mean, it's not a huge deal. I also do need to work on getting some descriptions up on my videos that I posted, both video on demand and over to YouTube, to try and tell people what are actually in them. Go figure, people want to know what's in a video. Okay. So, we had talked last time about doing integration by parts in Calc II. And, this is also a little bit too thick here. Let's back this off. It is backed off. Okay, cool. So, one of the other integration by parts types that are kind of come up a lot in Calc 2 are things like this, where there is, for instance, x natural log of x dx. So in this particular case, just like all of our previous examples, the x is something that when you differentiate it, it ticks down. So it makes it a lot easier to use x as your u, which is then going to be differentiated. So u equal x, du equal dx, and therefore dv is equal to natural log of x dx. And therefore v is equal to the integral of natural log of x dx, which is going to be 1 over x, provided that x is then positive. Keeping in mind again, right, since we have just natural log of x, it's not the absolute, not the natural log of absolute value of x. This is automatically restricting the domain. Excuse me. The family spent most of the afternoon at the pool, so I'm like half sunburned, half exhausted. This is going to be fun. It's fine. We're fine. Alright, so then we're going to multiply u and v. Now here's an interesting thing. U is just x, and v is 1 over x. So then uv is going to be x times 1 over x. This is just going to be 1. It no longer has any variables in it. So this makes it kind of interesting to say like, oh, well, if at some point we come across something that just has ones, we can remind ourselves that this might actually have the same function both top and bottom, and it will divide out nicely like this. Alright, minus integral of v du, which is going to be 1 over x, times dx is just, or du is just dx. Okay, so minus, here we take the integral of 1 over x, and interestingly enough, right, this ends up being the natural log of x. We already had from above that the domain was restricted to just the positive region, so this is also going to be restricted to the positive region. So 1 minus natural log of x, provided that x is positive. Alright, in doing so, there's also a nice little consequence of this, in that we could also potentially have something like the integral of the cosine of the natural log of x dx. And in looking at this, we're saying, well, there's only really one function here, so what are you trying to do? Like, it doesn't make any sense to think that this is potentially anything. However, when we look at this, you got to think, okay, if what we're trying to do is we're saying if this is going to be a function, then we would want to have, let's say, let u be equal to the cosine of natural log of x, and v is just going to be dx, just as it is. Right? We'll start with an initial guess. Essentially, this is what dv. dv is just dx. We'll start with this and say, all right, where do we go from here? If this is true, what is du? This says that du is going to be the negative sine of natural log of x times the derivative of the inside of this is the derivative of natural log of x, which is 1 over x. Which means that v here is just going to be x, and v du, when we have this here, is just going to end up being negative sine natural log of x, because now we have these pieces. So u times v is going to be potentially x cosine of natural log of x minus integral of v du is going to be negative x sine of natural log of x dx. All right, dx here. All right. So this is going to be equal to x cosine of natural log of x plus integral x sine of natural log x dx. Lost my cursor. There we go. All right, now this is not possible. So again, we're going to have to do the same thing. And this time we're going to have to let u be equal to... Oh, this is different. Sorry. Let u be equal to x. This might undo everything we wanted to do here. This is a good thing. All right, we're going to just... let's experiment. Let's see what happens. So if we let du be dx, then dv is going to be equal to the sine of natural log x dx. Therefore, v would have to be all right, so we would have to have in order for this to be true, in order to take the integral of this thing, we have to have a u-substitution that has 1 over x on the outside of this. Yeah, just basically like this thing. Yeah, I think this is going to undo everything and just cause it to be the integral of cosine of the natural log of x dx is equal to itself. So I think we have to go back to the previous one and alter it in order to have something that is slightly different. Let's just check this real quick. 1 over x trig of natural log of x dx, and v is equal to x. Okay, cool. Alright, so they actually decided... Alright, let's not undo everything and go back to the same place we were. Let's actually continue exactly what we've been doing. No, hang on. Oh. Yeah, that's what I forgot. There's a 1 over x there. So this has no x. Extra x. Just the integral, the sine of natural log of x dx. Okay, there we go. No wonder it wasn't working. Alright, so we do the sine of natural log of x is going to be u, dv is just going to be dx. Consequently, then v is going to be x, and du is going to be the derivative of this, which again is just going to end up being 1 over x times the cosine of the natural log of x dx. So this is equal to x cosine of natural log of x plus, now this one is going to be replaced with uv is x sine natural log of x minus the integral of v du. How am I doing on space? Plenty of space. All right. V du is going to be x times 1 over x. So we're back to cosine of natural log of x dx. So this is very similar to just the sines and cosines functions that we had before, where it was mixing something like e to the x. So e to the x sine of x, or e to the x cosine of x. You have to do integration by parts twice. It'll cycle back around to another cosine like we had at the beginning. And now, since all of this is set equal to this original thing, the integral of the cosine of natural log of x dx, there are now, we can add them on both sides. This one gets added to the other side. Now we get 2 of these integrals is equal to this other stuff. Alright, so integral of cosine natural log of x dx is equal to... close enough. Is equal to x cosine of the natural log of x plus x sine of the natural log of x minus integral cosine of natural log of x dx. Alright, so once we do that, then this stuff will kick over to the other side, and then we're going to have 2 integrals of cosine of natural log of x dx is equal to x cosine natural log of x plus x sine of natural log of x. And then we divide both sides by 2. So the integral of the cosine of natural log of x dx is equal to 1/2 x cosine natural log of x plus 1/2 x sine natural log of x. All right. So repeated integration of parts is kind of like this concept that's just going to keep coming back over and over again. We're going to end up getting a repeated pattern that we end up coming up with at some point. You then take that pattern, and because it's the same as the original, you can add them onto both sides or subtract from both sides, whatever the case may be, and you end up with some number of the original integrals times whatever. There is also the possibility that you could come up with a nonlinear coefficient out front. So instead of 2, this could have been like, I don't know, x or x plus 3 or something crazy like that. It could happen. It doesn't happen, as far as I know, very often. I have not seen it myself, but other people, I'm sure, have examples that they've come across where that does happen. And again, just combine like terms. Get all of the integrals that are exactly the same over onto one side, and et voila, there you go. It ends up being exactly the same as the original. I just hit Winamp. Why is that button there? Alright, another example that has been done before. Sorry, not on this channel. Another example might be something like take the integral of t to the third of e to the, even this one we could do t to the third dt. Okay, and with these values here, again, if we want to do a u-substitution, that should be kind of your first move, is to say, how do I do u-substitution with this? Well, u would be t to the third, so therefore du would, or should be equal to 3t squared dt. So here we don't have that out front, and it's not going to be a constant multiple of that thing either. So in this particular case, we can't actually use simple u-substitution in order to solve this. However, we can, because we were looking at doing a u-substitution for this, well, we could actually do this as our u. So take t to the third and let that be our u. And then this time do integration by parts with it. So instead, we say that dv is going to be equal to, and in fact, we don't want, no, that's not what we want. We want to select dv first. All right, dv is what can we get out of this that is going to be a usable integral. So here we have t squared e to the t to the third dt would actually work. So t squared e to the t cubed dt has a nice integral. And here we're going to use that. We don't actually have the numerical value out front. It'd be nice if we did. So if we could do a 3 here and put a 3 out in front of this one, then we would have to balance that out by multiplying by 1/3 as well. So then this would be 1/3 times the integral of t is going to be left over. So it's a spare out of this t cubed. So just t. Times e, nope, that's not an e, 3t squared e to the t cubed dt. Right? All of that is now going to work. Right? So therefore, v is going to be e to the t cubed. And u, therefore, is just going to be t. And du is just going to be dt. All right. So with that, now we can say this is going to be 1/3 times the quantity, and now do regular integration by parts using these pieces like we outlined up here. So it's going to be uv is going to be t e to the t cubed minus integral of du times v, or v du. So this is going to be just dt times e to the t cubed dt. Now we've got a different problem here, in that we have an integral of e to the t cubed, and we can't necessarily do anything with that, because we don't have another t squared out front. Hooray! So we've basically reduced this to a different problem that will need to be solved somewhere else. Oh boy. This is equal to integral of t cubed e to t cubed dt. So anybody who's out there, thank you very much for coming in. Your attention to the channel is most appreciated. Yeah, that's not going to be nice. So my name is Obi-Wan Pez. This is N Simplex Pachinko. Typically what I do is on Wednesday nights I have a math stream. Welcome to it. I have been trying to get a Monday morning math stream off the ground, but this past week was just not happening. And kind of unfortunate, but we'll see how it goes next week. If there is more demand for it, I will do more math streams, for random homework help and things like that. And on Friday nights, as well as whenever I feel like it, I will also do game streams. I am currently working on Control. I have been working on Risk of Rain, the first one, and fairly shortly I think we're going to start getting into the second Risk of Rain, and then maybe play with some other people who are out there. We'll see how it goes. If I'm going to do a stream where I'm playing with people, it will be people that I have played with before, or that I know, or that are from the community. I'd rather not play with complete random strangers and get all sorts of, shall we say, colorful language on the stream. Whereas I can't guarantee that this stream is family friendly. See the Spectrum Retreat. I do try to keep my Boy Scout summer camp filter on my language. So again, I can't guarantee that if I just pull random people in. So. All right, so you know what? Let's jump a bit. Dressiness. Evening. Right now I'm trying to decide on, just thinking about looking at numerical integration. So if you are in Calc II, that would be potentially helpful. If not, however, you know, you can let me know and I will move on to something else. If you have any questions yourself, please feel free to ask in the chat and I will get to it as soon as I can. So let's actually use this example that we had here. Let's use this example we had here to take the integral of e to the t cubed dt. And let's say that we wanted this. Let's see. The original was t cubed e to the t cubed dt. So let's add some limits of integration to this and say that we're going to go from, I don't know, -1 to 3. That's really big. -1 to +1. Let's just do that. It's much easier. All right, in the case of numerical integration, basically what we're trying to do is we're going to find a particular functional value we're going to find a particular area under the curve, e to the t cubed dt looks more or less like this. Okay, -1. It's right about here. And +1 is, well, by my terrible drawing, it would be here. It is a bit further up on the curve. Something more like that, give or take. And what we want to do is figure out what the area is underneath the curve here. So if we wanted to, we could figure out what the actual values are for this particular function at -1 and +1. It's okay. It is just going to end up being e to the -1st and e to the +1st in each of these locations. So it's not really surprising. And that's not really what we're looking for anyway. So we're trying to find the area underneath the curve here. So for this, there's no actual way to analytically get this solution, at least that we have discovered. Looking up the solution on Wolfram Alpha, there's all sorts of gamma function stuff, so yeah, we're not doing that. So instead what we're going to do is we're going to say, okay, let's go back to like Riemann sums. So one way to figure out the area under this curve is to look at the Riemann sum, which is the definition of how to get the integral in the first place. So In the case of Riemann sums, what we have is that an integral of some function f of x dx between a and b is going to be approximated by the sum as I goes from 1 to n of f of x sub I times delta x, where technically you could also put delta xi because all of your delta x's don't have to be identical all the way through. It's just much cleaner if they are. Alright, in this particular case, we could actually have a pretty wide delta x around this middle section because it doesn't change very much. So our delta x could basically be from like the delta x that's surrounding 0 could essentially be from like negative a third to positive a third, like give or take. Somewhere in there you could have this whole section which is worth 2/3, which is roughly going to be identical. Or it could use up that whole space, and then we don't have to worry about all sorts of stuff. Okay. In the case of Riemann sums, what we do have is we can look at it from either the left perspective or the right perspective, or from a midpoint perspective. And we can do either one, or any of those three. So, okay. Still not blocking myself off. So left Riemann sum is basically going to say that we want a sum. The x sub i's are going to go from 1 to n, or you could argue we could let them index instead from 0 to n minus 1. It's up to you if you want to change the index or if you just want to change your different values going all the way through this whole thing. Typically, I will change the indices just because it's slightly easier to think about in my terms, but anybody else comes up with a different idea, you're welcome to use it too. Alright, so we use f of x sub I delta x, and again, I'm going to use delta x just as a single thing. This is going to be the same as going from I equals 1 to n of f of x sub I minus 1 delta x. So we change the index on the inside, or we can change the index on the outside. That's one of the ways to do it. Hey, Kiwi Gamer. Yeah, I think I'm going to submit two ideas. So my first so my first was going to be the absolute values. Invention that I have done. Which, I mean, it's not a super big invention, but it's another way to explain something in the classroom that's going to help connect students a little bit better. That is the visual idea here, where, like, you know, x minus c is going to, absolute value x minus c is less than, d, distance. Then I'm going to draw my c at this particular location, that's my target, and then d is the distance between it and the possible solutions. This one therefore ends up c minus d, this one ends up c plus d. And then since we're looking at less than, this was going to be a smaller distance. So how far are we going? Well, it's less distance than this d is out here. So this is the outer limit with open circles because you can't be there, and then shade everywhere in between. Yeah, so I'm also kind of wondering if that one's already done. I mean, Grant himself has probably done something, at least... He's probably done some on E. I definitely don't want to, like, you know, copy anybody's stuff, even accidentally. Category theory. Yeah, I'm not terribly well versed in category theory. In fact, I may not even know it by name. Oh, I think you and Matthew would have some pretty good discussions. So my other one was a project-based approach to the unit circle. So it basically starts out like, let's discuss this as if it were just, you know, standard unit circle. Alright, sorry, let's... So let's start this as if it were like, you know, find the circumference. Of a... When I did this, it was in the context that I was eventually going to, like, create this whole kind of idea behind everything to say, like, okay, the Ferris wheel is one object inside of this, like, amusement park that you are running. And so, like, all of the students in my class were gonna, you know, run this amusement park and have all sorts of... It was a cutesy idea. Yeah, I haven't done complex angles, I don't think. Which is interesting because we did, I did take complex analysis. So, like, I knew at one point how to take an integral in complex numbers, like in the complex number system, of something that involves sines and cosines and all sorts of stuff like that. But yeah, we didn't really... It'd be something worth investigating, but yeah. Let's see. There's also something, I'm sure there's something in differential equations that I probably do differently than, you know, half the teaching world and would probably want to get that out there, but like I can't think of anything, and I got to go back through my notes and figure out like all the differential equation stuff. All right, so like the idea that I had done here was, okay, we're going to find the circumference of a Ferris wheel, and it's just going to be like that's too big. R is going to be 100 feet. So your radius of the Ferris wheel is 100 feet. Then what is the circumference? And so this ends up being 100 times 2 pi. And then we say like, okay, well, what if you only want to put lights on like, you know, half of it or whatever? Okay, well, it's 100 times just pi. How'd you get that? Well, it's a half of that. What if you only wanted to put lights on 1/8 of the entire wheel? Well, that's 100 times 2 pi over 8, or then pi over 4 times 100 is going to be 1/8 of the entire wheel. So then what about if you wanted to do one that only had lights on 36.3 degrees of the entire circumference? So then students look at this and be like, okay, well, cool. So eventually somebody figures out, okay, this is going to be 36.3 degrees out of 360 degrees, gets us a proportion of the wheel, which is the same thing that I had been doing before with, you know, 1/8 of the wheel. Right, this is the same thing, it's just a matter of saying like, yeah, and I mean that's kind of one of the things that you saw the video, right? So that's kind of one of the things that he was saying in the video was that like I really want to get teachers doing this stuff because we have been in the classroom and we have gone out there and like tried to teach this stuff, and we know what works and what doesn't for any group of students. Now, it might be completely different when it's on the internet, but you know, or we get higher production value for talking with people and doing all this stuff. So yeah, so I was like, well, you know, it'd be really nice if this happened, but there are so many better people than me. You know, I'll submit something and be like, hey, let's try it. So then, like, students come up with a formula for there. Students come up with a formula for how much of the wheel is being lit up based on the proportion of the wheel that they want to light up, and then, you know, substitute out the radius as well. So then the length of the lights that they're going to use to light up the wheel are going to end up being the radius times, well, I guess capital R, but the radius times the proportion of the wheel that's being lit up. So this is their angle over 360 degrees. This angle is in degrees. So then the units end up dropping out from these things. And they're like, that's kind of interesting. And then I say, okay, well, let's look at this in terms of let's look at this in terms of just the wheel itself. So like if you wanted to know if you wanted to know how far around is any point on the wheel from this particular point, what would you do? And that's like, oh, well, that's going to be looking at the circumference of that wheel from this particular point, and we're going to arbitrarily say that this is going to be positive. Or rather, not arbitrarily, because this is opening into the first quadrant. So we put all this stuff into standard position, and then we start opening up this angle from 0 all the way into the positive region. And then, if we go all the way around, that's going to be 2 pi. Or 0, because we didn't go anywhere. If we open it only halfway around, that's going to end up being pi. Only a quarter of the way around, well, that's half of that half that we just had, so that's pi over 2. If we open it 3/4 of the way around, that's going to be 2. Nope. Wow. No. 3 pi over 2. And then the easy ones are going to be, we'll take those and chop them in half again. So pi over 4. And then we can also count, which is another nice thing here. So we go from here, if we count, this is 1 pi over 4, this is 2 pi's over 4, this is 3 pi's over 4, this is 4 pi's over 4, this is 5 pi's over 4, this is 6 pi's over 4, this is 7 pi's over 4, and this is 8 pi's over 4, or just 2 pi. And then some of the other angles that we know in trig, which are kind of nice, are 30 and 60 degrees. So if we cut these this way, then this increments by 30-degree angles, or this is going to be pi over 6 all the way around the circle. So this is 1 pi over 6, 2 pi's over 6 is pi over 3, 3 pi's over 6 is pi over 2, 4 pi's over 6 is going to be 2 pi over 3, 5 pi's over 6 is going to be here, 6 pi over 6 is here, 7 pi over 6 is here, 8 pi over 6 or 4 pi over 3 is here.
Yo, what's going on?
8 pi over 6, 9 pi over 6 is down here, 10 pi over 6 is here, so that's 5 pi over 3. 11 pi over 6 is here. 12 pi over 6 is back at the beginning. Alright, and then to be consistent, you notice that all of these internal angles here are 15 degrees apart, or pi over 12 apart from each other. So pi over 6 plus pi over 12 is pi over 4. Pi over 4 plus pi over 12 is pi over 3. And then also, there are nice pi on 12 angles, which are between these blue ones and the axes. So that is 5 pi over 12. 7 pi over 12. This is 11 pi over 12. 13. This is 16, this is 17. So these pi's on 12 are irreducible. Obviously, I'd want to make this A bigger and B not overlapping with each other, and, you know, there's all sorts of stuff. But then this creates the idea of the unit circle, and all of the black and blue ones are nice angles, which then you can use standard, easy trig stuff in order to figure out, I mean, it's basically geometry, in order to figure out the side lengths versus the angles. And yeah, this actually becomes super easy for figuring out the unit circle. So there's a lot of stuff that we can do with this, but it's a lot less interesting. It's already well trod. I have a feeling that the absolute value thing might catch a few more eyes, but again, I'm willing to create 2, 3, 5 videos in order to submit them and have people look at it. Just be like, oh, that's something slightly different. But I don't know, maybe. Um, yeah, this is the other thing, is that I'm not anywhere near as good of a casual explainer of how things are working as, say, Grant or Sal Khan from Khan Academy. I'm much more formalized in my approach. I am much more academically oriented because I'm a teacher. It's kind of just how I do things. And especially since I'm a teacher at the college level, I have students who are from, you know, Algebra 1 all the way up through differential equations. So there are quite a lot of there are quite a lot of you know, differing perspectives on mathematics as well as on mathematics in general, as well as just life experience. And you've got people from all walks. It's great. Not seeing anything like offhand that would be particularly revolutionary. Really, I just need like 10 more classes in differential equations, and I'll be golden. I'll come up with something. I mean, that's basically what happened here with the absolute values, was that I just had taught it so many times, and at one point I was like, okay, look, let's talk about this in terms of like distances from this target value. So this is your target, C, and then your distance from that, D, is going to get you, like, you know, we don't care what direction it's going in, it's just a distance. And then, you know, the outer edges can either be open or closed, depending on whether you have less than or equal to, or greater than or equal to. And then we shade either inward or outward, depending on, you know, whether the distance is less than or greater than that particular value. Well, I also need to get editing onto a few of the videos that I do have, and not just post my live streams, but actually do some real stuff on my YouTube channel. So youtube.com, search out nSimplex Pachinko. I'm down there somewhere. And that is going to be for my mathematical content. It's going to be pretty much all the same stuff you see here. I haven't done a real edited video in quite a while, so I'm going to have to get back into that. Alright, shy of anybody coming in and asking more questions, I think I'm probably going to raid over to Jason Charles Miller, who is doing his Whatever You Want Wednesdays. I will talk more with all of you. I will talk more with all of you. Let's see. Friday night is going to be a game stream. Tomorrow I'm probably going to be just offline doing stuff, either editing videos or trying to come up with a better script for what I'm going to be doing for 3 Blue 1 Brown. or potentially just messing around with friends who are not streamers or not going to be on stream. So we'll see how things go. I hope you all have a good rest of your week, and good luck out there. This is Obi-Wan Pez for N Simplex Pachinko. Have a good night.